Hey, Kurt here. Today I'm going to give you an introduction to AppleSoft Basic on a working Apple IIe computer. Now, the Apple IIes were built between 1983 and 1993. My particular PC that we have right here was actually built in 1983, the first year of production. I took a peek at the serial number just out of curiosity, and my serial number is just over 229,000. Now, these PCs were manufactured with 64 kilobytes of RAM, or program memory. Now, 64 kilobytes by today's standards is very, very tiny. Today's PCs usually have about 4 gigabytes of RAM. These were upgradable to 1 megabyte of memory. My Apple IIe actually has double what the manufacturers created it with. Mine has 128K of memory because mine has an 80 column card, a text extended memory card, and these 80 column cards were very popular among consumers, and actually in the later years of manufacturing, Apple actually provided those 80 column cards standard with these Apple IIes. And during that time, many popular programs even required that card and the extended memory. They required 128K of RAM just to run. On this computer and on a lot of others, programs are actually stored on cassette tape or floppy disk, and then they're loaded into RAM before running. Now, 64K doesn't sound like a lot of memory, but this operating system that came with these Apple IIe computers and all the programs that came with these computers really were much simpler back then, and they totally fit into 64K or 128K for some of the more complex programs. Now, if this video piques your interest and you would like to play around a little bit with AppleSoft Basic on your own, and you don't have access to a working Apple IIe computer, there are several emulators out there on the internet that are really great, and some of them are a little bit limited in what they can and can't do, but I will link my favorite emulator that I have found very few, if any, limitations with. I will link that down in the description so you can check it out yourself. Now, let's get started with our introduction to AppleSoft Basic. Alright, all we need to do is power on the CPU and the monitor. I have them both connected to this single switch. You can hear the disk drive going, but I don't have a disk in there. We're going to boot directly into AppleSoft Basic by hitting the control reset, and that tells the Apple IIe that don't bother looking for a disk, just dump right out into AppleSoft Basic so we can start typing our programs or our command lines. Okay, the first command we're going to try is called home, H-O-M-E. And home simply clears the screen. Now I want to point out, if I turn the caps lock off, that all commands on the Apple are uppercase, and it does not understand lowercase commands at all, as you can see. With AppleSoft Basic, just like any other basic language, you can print things to the screen. Here we've printed 6, and white space does not matter. The white space is really just there for us human programmers. Most computers do not care about white space when you're programming. Now, let's look at variables that are numeric. So if I tell it to print the variable x, it's going to print the value of 0 because x has not been set because we just booted up the computer. To show you the difference, if I put quotes around x, that's actually printing the string x, not the value of the variable x. Now, if we actually set x with the let x equal and put in some value, and now if we print x, it's going to show us that the value is now 14. Now, I want to show you that the Apple IIe does take variables of different lengths. If I set time equal to 1, 2, 3, it lets me do that, and I can verify that by printing time and see that the value of 1, 2, 3 is there. But under the hood, the Apple IIe only uses the first 2 characters of variables. All the other characters past the first two are completely ignored by the Apple IIe. So I can pick out another variable like timely, and I can set it to a different value. To most programmers, time and timely are two different variables, but to the Apple IIe, they are the same. So when I print time, it's actually going to print 999 instead of 123. And actually, since it only cares about the first two characters, I can say print ti, and I get 999. Now, let's look at variables that are string type. What the Apple uses for strings is the $sign. When I'm programming, I usually call it string, like I will say let a string equal something instead of saying let a $sign equal something. But that's just me. Everybody has their own personal preference. So if you hear me say a string, that's what I'm talking about. So if I print a string after I've set it, you can see that's how AppleSoft Basic handles string type variables. I didn't have to allocate memory. Basic automatically allocates memory for variables when we create them. One interesting limitation, although I don't know how many people ever actually hit this limitation, is that strings can only be 255 characters long, no more than that. And if you try and create a string that's more than 255 characters long, it will not chop off the extra characters. It will actually give you an error. Okay, now we're going to move the cursor around the screen so that we can format things nicely on the screen. The screen of the Apple IIe has 24 lines of text. So let's do the home command to clear the screen, and then the command to move the cursor down is called VTab or vertical tab. So let's jump down to line number 10, and you can see the cursor jumped down. Now, as far as columns, the screen by default has 40 columns of text. We are not in the 80 column mode on this computer right now, so it only has 40 columns across. So if I do an HTab 40, which should bring the cursor over to the right side, and I hit return, it doesn't look like it did anything. Well, actually what it did was it did move the cursor over to 40, but then when that command was finished, it brought the it did a return character and printed out the command ready character and the cursor. So for us actually to see the horizontal tab work, let me do a home again, and let's put multiple commands in a single line. Let's do a VTab 20, which will go down to 20 out of 24. And then on the same line, let's do an HTab 10, which will bring the cursor over 10. And then on the same line, let's actually print some text. Now, when we do that, it went down 20, over 10, printed hello, and then it did the return character and drew the ready prompt for us. Alright, next, let's do a little simple math from the command line. If we print 2 plus 2, we get what we expect. It's doing the math for us, and it's giving us an answer of 4. It's printing the result of 2 plus 2. If you want to look at decimal places, this is going to give us an infinite answer, but it's not going to draw it out infinitely. The Apple gives us 9 decimal places. If we do another one, 200 divided by 3, that's actually going to round up on the last decimal place because it's 6666 forever, and it rounds up on the very last decimal place there. Now, under the hood, inside the processor, it's actually keeping track of more than 9 digits, but it only prints out to the screen by default 9 digits. Now let's look at some of the common error codes. If I mistype a command completely, like HO, if I spell home wrong, that's a syntax error. You'll get that a lot for typos. Another type of error is if we try and VTab past 24, that's not allowed, and so we get an illegal quantity error. if we do that. Another common error code is divide by zero error. We can actually overflow the processor if we put in some really large numbers, 2 to the power of 20 times 2 to the power of 20. That will actually overflow and give us an overflow error. So the processor can't handle a number that big. Now, if we're not remembering the difference between numeric variables and string variables, and we try to set a string to a numeric type variable, remember this needed to have a dollar sign after it in order to make it a string variable type. If I try and do this, I get a type mismatch. And the last error I want to point out is the rounding error. So 9 times 9, everybody knows, is 81. So 9 to the power 2 should give us a simple answer of 81. But because this is a processor from the early 80s, it does have some small amount of mathematical error that builds up, and so this is a good example of a very simple math problem that this computer doesn't quite get exactly right due to a small rounding error. Now, all the commands that I've typed in so far have been just single commands that are executed on the command line as I type them. As soon as I hit the return character, the command I typed in is executed. Now let's write an actual program that will execute in sequence in the right order. And we're going to type these lines of code directly into the computer's memory, or RAM, which I was talking about earlier. I do not have a disk in the disk drive. This computer does not have a hard disk. It doesn't have an internal disk at all. I'm not going to bring up a text editor. There will be no text file that is saved anywhere. We're in AppleSoft Basic. You essentially just create your lines of code directly into RAM, and then if you want to save them to disk later, it lets you do that. For this demonstration, we're not going to save anything to disk. Now we can type these lines of code in any order we want to, because each line of code that we type in is going to have a line number associated with it, and so we use these line numbers to tell the computer in what order we want it to execute. So let me clear the screen, and the command called list actually lists the program that's currently in memory. So right now there's nothing in memory. So if I start typing a program with line 10, and then I let k equal 99, and then I type line 20, and then I say print k. Now if I do a list, we will see those two lines are in memory, and all I do is type run, and it will run that program. Now if I want to add a line in between line 10 and 20, I just have to pick a number between 10 and 20, like 15, and then I type my line, k equals k plus 1. If I list my program, it shows me the program in order that it will be executed. And now if I run it, it's no longer 99, it's 100. Now let's say I wasn't happy with line 15 and I wanted it to be different. I could just type in a new line number 15, and this new line number 15 will replace the old one. So now if I list my program, there's the new line 15, and when I run it, I get 88 this time. I can also add another line at the end. I can say print all done, just to let me know, whoops, listy. Now if I run it, I'll get the 88 and the all done. AppleSoft lets you start running your program from any line number, and this is very useful for debugging. So if I wanted to run this program straight from line 30, I would just type run 30, and I'm going to get the all done, but none of the lines above 30 actually were executed. Let's try and run it. What will happen if we run it from line 20? Well, line 20 prints k, but since we started at 20, k was never initialized, so it was 0. And again, you can probably imagine what happens if we run from 15. It's going to subtract 11 from 0 and print out minus 11. So we can also edit line numbers using an escape sequence. So if I list the program again and then I hit the escape button, you're not going to see anything right away, but since I hit the escape key, I'm now able to use the arrows to go up to line 30, for example, and then if I hit the escape key again, now I'm in normal typing mode, so I can just cursor all the way over to the end, and then I can add a little bit more text, and as soon as I hit enter, it has entered a new line 30 into the program to replace the old line 30. So there's my new line 30. When I run it, there you see it executing. So this is basically the way that people like myself in the early 80s wrote programs on an Apple IIe. We did not use text editors. We didn't have Notepad. We didn't have any integrated development environments. We typed our programs directly on the command line and had to debug them basically in this manner that I just demonstrated for you. Okay, now let's do some drawing on the graphics screen. The low resolution graphics mode has 40 rows and 40 columns, and it's capable of drawing blocks in 16 colors. Now, I have a green phosphorus monitor, so we're only going to see green, but I'll show you some screenshots later on of what this looked like on a color TV monitor. Now the rows and columns are accessed using 0 to 39 values, not 1 to 40 as we saw earlier with the tabs. So the drawing coordinates always start with 0, 0, while the text tab coordinates that we saw earlier started with 1, and that's probably an artifact that's left over from the typewriter era when tabs started at character 1 and line 1. Alright, now we get into the low resolution graphics environment or mode by typing GR. And watch the screen. It kind of cleared, it did a little funny thing there. Now you can see there's still text at the bottom. This low resolution graphics mode includes 4 lines of plain text that are reserved at the bottom of the screen. But above those 4 lines is all turned into a graphics mode. So we can do some graphics commands like color equals 15. That sets the current color, I guess you'd say. Now that almost, the word color almost looks like a variable, but this is really a special function, or maybe it's a reserved variable that you're not allowed to use anywhere else in your program. But you know, for example, if I do print color, you know, that gives me a syntax error. Now in order to put a block of that color, oh, I do want to mention that color 15 is white, which will look green on this green phosphorus screen. So in order to plot a pixel, so to speak, now these pixels are really big because it's only 40 wide and 40 tall. So we're going to plot a pixel at coordinates 20, 10. So that's going to be 20 over and 10 down. So it's about in the middle of the screen because it's 0 to 39. So 20 is, you know, about in the middle of the screen, and 10 down. So that's what white looks like on a green phosphorus screen. Now if I change the color to 1, 1 is actually red. So if I plot a red pixel or dot or block is really what we like to call them when we're in low res mode, it's going to print a red block over here. Now you can see that this was white and this was red. On the green phosphorus screen, it shows different colors using different patterns. Now if I change the color again to 2, that's actually the color blue. And if I plot a third block a little bit farther to the right, that's what blue looks like. It almost looks the same as that one, but it's a slightly different pattern. Since this camera is kind of low resolution, here's a screenshot, which is a close-up of what these green phosphorus blocks look like on this screen. Now, here is a different screenshot that shows all 16 of these low-res colors, and it's captured from an emulator, but it basically looks almost exactly what it would look like on a color TV monitor. And now here is a little cheat sheet that shows the 16 colors and their designated numbers that the Apple inventors came up with for these 16 colors. And so we're going to stay in this low-res graphics mode until the Apple gets the command called text, and then it will change it back to text mode. Alright, now we're going to play around with drawing in the high-resolution graphics mode. Now for the Apple IIe, the high-res mode only has 280 columns across, and it only has 160 rows or lines. So that's 280 pixels by 160 pixels. Now standard VGA, which is a pretty old standard, actually has 640 pixels by 480 pixels. So you can actually fit more than 6 of these Apple IIe displays inside a single VGA display. So this high resolution mode in an Apple IIe is really not all that high resolution. It's very, very low resolution by today's standards. But it was pretty awesome back in 1983. Did I mention that the high-res mode only has 6 colors? Now to get to the high-res graphics mode, you just type HGR for high. Now, again, 4 lines are reserved at the bottom of this high-res graphics mode. Now, to change the color, it's a very similar command. It's HColor instead of color, and 3 is reserved for white in high-res graphics mode. So to plot a single pixel, we use the hplot command, and we put in our coordinates 140 and 80. It's going to give us a single little white pixel somewhere in this area, and so watch it, 3, 2, 1, mark, there it is. Actually it's green on the green phosphorus screen. Now if we wanted to plot a line, that's actually very easy. We do an hplot, and then we put in the first coordinate, and then the word 2, and then the second coordinate. And now we have printed a line. Now that is a white line. Now if I change the color, HColor equals to 5, that's orange in the high-res graphics mode. So if we plot another line starting from where we left off at 210, and then we go down and to the right to 240, 80, you'll see an orange line as shown on a green phosphorus display. So you can kind of see there's a pattern here. If I was drawing something that was filled in orange, the pattern would become pretty obvious that it's not just solid like this white one is. So here's a close-up view of the pattern. Since my web camera is not very high resolution, this is a close-up screenshot of what this looks like, and you can see the different patterns showing up for the different colors. Now here's a screenshot of the 6 high-res colors as they would show up on a color TV monitor. Again, 6 colors is all you had to work with back in 1983. And here's a cheat sheet that shows the 6 colors and their designated numbers. Now, I'm not sure why there are actually 2 blacks and 2 whites, because there are actually 8 total color numbers that you can pass to the HColor command, but there are only 6 unique colors. Okay, we're almost masters of AppleSoft Basic now, but there's one last thing I want to demonstrate, and that's making sounds using the built-in speaker. We heard the standard beep, which comes out of the speaker when there's a syntax error or something like that. And that's the standard Apple beep or bell sound, and that's basically built into the system, and that is sounded whenever you print the ASCII character 7. So if you're familiar with the ASCII chart, or you just want to Google and bring up an ASCII chart, you'll see that decimal 7 is the non-printable bell character, B-E-L-L, bell. So the Apple IIe inventors basically hard-coded this default error beep or this default user notification beep into that character. So let's do, let me get back into text mode and clear the screen. Now if we print ASCII character 7, now in order to access the ASCII characters, Apple has this special reserved function called $, and then you pass it the value, decimal value. So as soon as I hit return, 3, 2, 1, you can hear the standard beep because we've asked it to print the bell character, which is an actual audio signal. So if we wanted to get at the speaker at a more fundamental level and make different tones or make music, that's a little bit more advanced. That involves the magic reserved command called peek, P-E-E-K. And that command is reserved for calling special internal computer functions that do special things. So it turns out that peek with a value of -16336 is reserved for activating the speaker. So that's kind of weird, right? By itself, the peek -16336 command just does a single click of the speaker. Now I'm going to try it, but it may be too subtle and too quiet for you to actually hear on the video. So it's -16336. So when I hit return, be real quiet and see if you can hear the tick. 3, 2, 1. Okay, I heard it, but I don't know if you can hear it on the video because I don't have the microphone way down here by the speaker. But it turns out that different combinations of these peek commands will make different tones. So I'm going to actually write a quick program to make some tones come out of the speakers. So this is what my program looks like. It's just a simple for loop. This for loop will execute 100 times, and so line 30 is basically going to get executed 100 times. So this is what this program sounds like. I'll do it again. It's kind of a buzz. It's kind of a low buzz tone. Now if I change line 30 and add a whole bunch more of those peaks, bear with me because this will take a minute. Okay, now this is quite a few more of those peak calls than we had before, and earlier it did a low buzz. Now if we run it, it's a higher pitched buzz. So I know that's pretty weird stuff, but that's how the Apple engineers made the interface to the speaker, and it's not exactly user-friendly. Okay, that was a brief introduction to AppleSoft Basic on the Apple IIe. We went over the use of variables, both numeric and string variables, and then we moved the cursor around on the screen, which is useful for text games. We did some simple programming directly in RAM, and we played around a little bit with both the high-res and the low-res graphics modes, and then we played around with the speaker a little bit. So please feel free to comment on this video and let me know what you thought, or if you have any questions, or to let me know what else you'd like to see. So thanks for watching, and thanks for your interest. Bye!